All right. Hello, everyone. Thanks for joining us for today's webinar, The Recipe for Continuous Delivery. Just going to let everyone know a few things up top. One, we are recording. So if for any reason you need to leave early or you have a colleague who was unable to join, they will be able to view this later. You can also ask questions. We're going to have time at the end for questions. So please, as soon as you think of one, put it right into the question panel. Even if you think maybe we won't be able to get to it or we'll answer it in the course of the presentation, it's always good for us to know what people want to hear more about. After the session, a very short survey, basically just asking you what you thought and what you'd like to learn more about, will pop up. It's going to happen right after everything when I close this out. It's only about 4 questions. If you could answer it for us if you're still on, we'd really appreciate it. So I'd like to introduce our presenters for today. I'm really excited about this one. This is our first time where with Jenkins, we have this jam program, the Jenkins area meetups, where we have meetups all around the world for people to learn about open source Jenkins and Jenkins X and not worry about sales pitches. And the guy you're seeing on your screen right now is Marcelo Olivas, the CTO for Ticked. He runs our South Florida jam, and I will be putting links to where you can find your local meetup as well as the South Florida meetup and Ticked as soon as we get started. And we also have Victor Farsik on with us from CloudBees. He's authored the DevOps Toolkits books. He's pretty much done everything. I'm sure you've seen him present. He's everywhere all the time. And he's going to be joining us at DevOps World Jenkins World this year in San Francisco and in Lisbon, Portugal. So I'll be putting a link to those as well with a 20% discount code. Without taking up too much more of our time, though, I'd like to get started. So Marcelo, you want to kick us off?
Yeah, thank you, Max. As Max mentioned, I'm currently the Chief Technology Officer at Ticked, but I always keep myself busy with several side projects and consulting clients. So I'm really excited about this one too. So say, for example, in here, you just finished your project. Is code complete and it's time to deploy. Now, a lot of your friends have talked to you about AWS, and you decide, you know what, I feel like it's time for me to just start learning about AWS. So you end up going to AWS, you create your account, and you're ready to go. And then you stumble on this. So now you end up seeing this, and you get a little bit concerned because it's a lot of services, a lot of products, and you really don't know exactly what to do. But you end up learning and reading, and after a week later, you end up creating your first server. Now, say for example, this is just a Spring Boot server. I mean, it's a server running your Spring Boot code, and everything seems to be okay. But then you realize something. Well, that's just one instance, so that can be good. If it goes down, then my whole application goes down. So what else can I do to make it more resilient, to make it more highly available? So you start reading, and you end up reading about availability zones, auto-scaling groups, elastic load balancers. And after 2 weeks later, you probably end up having something like this. And once you have that, then you realize that this is a step further. There's some improvements, certainly some features, but then you realize something else. Well, this is all in public. This can be good, right? I probably might need to put everything, in probably somehow make it more private. And after that, you end up learning about PPCs. Probably you end up learning about the different subnets, private and public subnets. And if you have private subnets, then you probably are reading about NAT gateways, and also maybe you're learning about internet gateways. So after a couple of weeks of that, you end up creating something like this. And now you're pretty pleased with yourself, and then you talk to one of the things that you also figure out is that you're probably gonna need some more than one environment. Maybe this is your production environment, but clearly you need to have it there. Maybe you have a stage. So you're probably looking to some other tools like Terraform and Ansible to help you out with that. So now you're learning all of this stuff too. But then you end up talking to your really cool friend, and your cool friend knows a lot about technologies and tells you about Kubernetes and how amazing and awesome it is. And it tells you about the fact that, as Jane Strachan mentioned, that Kubernetes has become the de facto standard in orchestrating container. All public clouds now support some type of version of K8, including AWS and EKS. So he goes and explains to you that this is just the most amazing thing that you can do, and you decide this is exactly what I need, because your friend explains that, Kubernetes now is kind of like this operating system sitting on the cloud. So the only thing that you have to do is providing kind of like this contract where you said, hey, please run this web service, have 3 instances, and not only Kubernetes runs that, it makes sure to monitor all that stuff. So in other words, if any of those containers goes down, then it will make sure that another container gets spin up. And it also monitors your node. You can expand your node, increase the elasticity of your applications as well as your cluster. So it's just amazing. So then your friend tells you a little bit more about Kubernetes, especially EKS, and explains to you that, well, now you need to know about the fact that, you have a control plane and a data plane. The control plane is what is handled by Amazon, but you need to handle the control plane. And also, you might need to end up learning about some of the technologies, because clearly you need to know about Kubernetes. Also, it tells you like, well, also make sure you learn about Docker, because now you need to know about this registry stuff. Oh, and also keep in mind that you need to spin these guys up. You need to create kind of like this entire infrastructure. So maybe you want to know about CloudFormation. Oh, don't forget about the fact that you also need to know about creating all the different rules. So make sure that you end up focusing on your IAMs. Also, he tells you, well, also you may want to know about Helm, because otherwise you need to learn how you don't want to be in this mess of constantly monitoring and spinning up all these manifest files. And he tells you, also, you probably may want to look into Go. I understand that you know a little bit of Ansible, but probably you may want to do a little bit of help with Terraform. Also, you may want to learn about Python, because there's this library called Troposphere that can get you up with CloudFormation, so you can create this entire infrastructure. At this moment in time, this is the phase that we all face, right? At this moment in time, we all realize like, oh my goodness, the only thing that I wanted was just to have Kubernetes running all my applications. What is going on? This is probably the phase, the DevOps phase, what I end up calling. So anyways, moving over to Victor.
Oh, thank you. Okay, good. Show my screen. Excellent. Okay, let me just, where I was. Okay, here. Okay, so before I start talking about stuff, I'm going to execute a single command just to show you that I'm doing everything from scratch, so nothing is prepared for the demo I'm going to do. I'm just going to create a cluster and everything I need for continuous delivery, continuous deployment. I'm going to show you what that something is, but I'm just going to let it run in background while I explain what's going to happen. And explain also who I am and all those things. So let me see, is it running? My computer is freaking out, I see. Okay, what's going on here? Okay, sorry guys, I'm not sure what happened. Something terrible. Okay, doesn't, my God. See, I get nervous. I don't speak in public often. What the heck? Sorry, guys. Okay, here we are, finally. Yeah, finally. Okay, so my cluster is being created, and I can, oh my God. Okay, no, not okay, freaking out. Okay, so the recipe for continuous delivery. Sorry for the delay, things happen. So what I want to talk about is how should we do continuous delivery today? What are the processes, what are the technologies, and what are all the different ingredients that we should assemble, considering that we live in 2019, we don't live in 2010 anymore. And before I continue, this is how I look like. For those of you who never saw me before, my name is Victor. I work for CloudBees. I'm one of the Docker captains. I have blog, I have books, I have a Twitter account, and that's everything you need to know about me. That was short. Okay, so how long, now after you heard what Marcelo told you, how long does it take to create a fully operational, production-grade, secure cluster? It's fault-tolerant, auto-scaling, and it has all the software pre-installed and running for continuous delivery and whatever else you need, right? And now think about that question, and we're going to answer it in a few minutes. But before that, I'm going to explain what we consider as the requirements, what I consider as the requirements for continuous delivery. What do you expect from it today? And some of those things are logical, some of those things might not be logical. We're going to discuss that. First of all, it needs to be cloud native. There is absolutely no doubt today that everything we are doing is in cloud. Now, whether that cloud is public cloud, private cloud, does not really matter. I'm not now promoting public cloud. I'm not promoting vendors. You can set it up yourself, but it needs to have cloud-like properties. And one of the most important ones is that everything is a service. So if you're in infrastructure department or something like that, you're not supposed to receive Jira tickets saying, create me a cluster, create me servers, and all those things. Our infrastructure is cloud, meaning that it is a service to everybody who needs to consume. It needs to be cloud agnostic, because what you don't want, even though it doesn't look like that at the very beginning, what the last thing you want is to be locked with the vendor, right? You don't want to go to AWS or Azure or DigitalOcean or Google and wake up one morning a year later and realize that you cannot go anywhere else anymore, right? So our solution is to be cloud agnostic. It needs to work everywhere, no matter where that something is. It needs to be able to scale to any capacity you need, right? If you have 1,000 replicas of applications, there should be 1,000 replicas of applications. Nothing is going on in your cluster, there should nothing be running. Everything should go from nothing to something, from something to nothing, and so forth, so on and so forth, right? It needs to be highly scalable. It needs to follow everything as code principle. What that means is that no more clicking around, no more dragging and dropping. Everything is defined as code. Your code is code, your tests are code, your configurations are code, your build scripts are code, your pipelines are code. Everything code. This is not negotiable, right? We are not anymore treating people as if they are kids that know only how to click with the mouse. We are all engineers. We define everything is code. Does not matter really whether we are developers, testers, or infrastructure operations. Sysadmins does not really matter. Everything is code. It's a it's a known principle. We are not really. There is hopefully not much need to discuss it. What next? The solution needs to be very fast, right? I am a very impatient person. I cannot wait more than a couple of minutes for something to happen. If it's more than a couple of minutes, I freak out. Everything needs to happen almost instantly. That means from deploying your applications, from testing, getting a cluster, whatever you need happens almost instantly. That's the world we are living in today. And it needs to be very, very easy, right? I cannot expect every developer, every tester, every operator to know everything about everything. That's unrealistic. It takes a year to learn Kubernetes only, right? And on top of that, months and months to learn everything else required for what I'm going to present. And if we expect people to learn all that, that's simply unrealistic. Now, I encourage everybody to learn everything I'm going to speak about today, but those we should still cater people who want to simply have continuous delivery without going into so much detail. Okay, what else? How do we get there? How do we, at least how do we envision those requirements? How do we assemble all those requirements so that we have something reasonable that works, right? First answer is very, very logical. Design cloud native apps. All applications needs to be cloud native. If that means that you need to refactor your applications, so be it. If that means that you need to throw them to trash and write them new, so be it, right? And you will see that actually what I'm going to show you is a full refactor and very different from what you might be used to before if you used Jenkins in the past. Adopting containers and schedulers, again, that's not a mystery. Everything is running in containers today, and all containers are managed one way or another with a scheduler, and that scheduler today is Kubernetes, right? What else? Serverless. Serverless are here to stay. Now, some things are good use cases for serverless, some things are not. So it's not a logic that can be applied to everything, but what we're talking about today, continuous delivery, that's a perfect example of something that works amazingly well and better than serverless, simply because the number of builds we are running is oscillating greatly. Right now, you might have no builds happening in your cluster. Next moment, you might have 10, and the moment after 1,000, and then it might go to 0 again, right? So it's a very, very good example of something that would benefit greatly from serverless. We need to adopt a lot of new tools. Right, I know that it's hard. I know it's hard to follow, and I know that we are all used to the tools that we are using, but new tools are coming, and they're awesome. And not missing on them, not adopting them, would be a great misfavor to you, to me, to everybody, because they're made for a reason. And we need to remove the tools that some of the tools that we are used to, because simply they're not good anymore. Whatever was good 10 years ago is not good now. Actually, whatever was good 3 years ago is not good now, right? So a lot of new tools, and a lot of tools are going away. So how did we get there? Kubernetes, that's a given. If we talked a few years ago, we might have discussed whether it's going to be Mesos or Swarm or Nomad or Kubernetes. Now it's pretty clear that the only one standing is Kubernetes. Everybody adopted it. It's a de facto standard. Not much discussion anymore which container scheduler to use. Adopt Knative, a serverless solution. If you want to run something serverless, assuming that you're adopting Kubernetes, if you do want to run serverless workloads, you need Knative. And on top of that, if you want to run serverless builds, then you need Tekton. Those are today's standards. That's how we do it in Kubernetes. And actually, Tekton, together with Jenkins X and a few other tools, are the members of the newly formed Continuous Delivery Foundation. So serverless equals Knative. We need to switch into GitOps, right? What that means is that the only thing you're allowed to do is to push something to Git. You're not allowed to have SH access anymore. You're not allowed to do random stuff that some of you might be used to. The only thing that we are allowed to do is to write code and push it to Git. Everything happening after that push to Git is supposed to be fully automated and handled by processes running in our clusters, not anymore as something that we do. Okay, what else? Helm. If you're adopting Kubernetes, if you already adopted Kubernetes, you know about it. If you didn't, you will find out soon. Helm is a packaging mechanism in Kubernetes. It's equivalent to Yum in or RPMs or Chocolate in Windows. Many packaging mechanisms today, the one used for Kubernetes is Helm. If you want to package your applications, and you do, you're going to use Helm. So those are all the prerequisites if you're going to build something that is worthy of a challenge of 2019. And finally, there must be some kind of a quick start. It's because of what I said before. I cannot expect everybody to spend years learning all the details about the technology and only then find out that they're still not finished and they haven't done anything else. So CI/CD needs to be simple, right? Some people are going to go into details. Some people are going to learn all the intricacies of all the things I'm mentioning now and many others. But for many others, it needs to be simple. Say, I have this application. It is written in this programming language. It uses this framework. That's it. That's all I'm going to tell you. And I expect the system, based on that information, to do all the right things, to compile it, to test it, to build it, to deploy it, to promote it, and so on and so forth, right? A few indications about the technology used for an application, and that's all that should be required. So we joined a bunch of processes. We united a bunch of different tools, open source tools, write a lot of custom code, and created a bundle that is hopeful, and you will see soon, very easy to use and yet extremely powerful. Another huge change to what you might be used to from the past is that this is CLI and API first experience, meaning that UIs are there, but UIs are not where we go to do stuff. We do stuff, write commands, and operating things through APIs. UIs are there just to show you pretty colors, to show you maybe some additional information, but UIs are not used to operate the things anymore. If you want, you can, but unlike traditional Jenkins, which is basically UI based and very relatively bad, not to say horrible API, this is a completely opposite. This is API first, CLI first, UI second. On top, what else? We need an opinionated process. Because what was happening in past 12 years or whatever is the time frame since Jenkins emerged, we had a tool that allowed us to do anything we want. With Jenkins, you can do anything you want. Any process you can imagine, any type of steps that you can imagine, it can be done. This is a bit different. This is a process first approach, meaning that some people, a lot of people, well define the processes that work, right? There isn't an infinite amount of things we can do or permutations of things we can do for continuous delivery. It's relatively straightforward, and there is a process, and that process is here. The tools that I'm going to show you are all built around the process, not the other way around. We did not create tools that will allow you to do any process you want. We created the process and then the tooling that will allow you to execute that process. So going back to the initial question, how many of, I don't see you, I cannot, if you start raising your hands, I will not see them. But the real question is, how many people attending this webinar are experts in Kubernetes? And those of you who are experts in Kubernetes, how many of you understand and know how to create Helm charts? And when we filter it down, how many of you understand the details of Knative? How many of you understand the details of other tools like Scaffold, of ChartMuseum, KSync? Those are all the widely accepted tools in a community, and yet many people never even heard about them, especially not use them. And that's normal because nobody can follow everything that is appearing in our industry. And yet we expect people to use them. And on top of that, we need to add GitOps as a major paradigm. Basically, everything around CI/CD today is turning around GitOps and Git chat, simply because Git is the only acceptable code repository format right now, and we accept everything to be stored in Git. That's the only source of truth, and everything is operated through Git, not through the tools. Tools are invoked by Git, not the other way around. So how many, let me see whether my demo, I'm still creating my cluster, so I need to speak for a minute or two more. So once, if you don't understand all the tools that I just mentioned, and the processes and paradigms and all those things, and assuming that we all live in 2019, how do you plan to be competitive? How do you plan to be better than your competition if your competition is adopting them and you're not? I mean, if you are, then that's great, amazing, power to you. If you're not, you have to, right? Simply because that's the nature of our business. That's how we are operating right now. So what I'm going to show you is a quick demo of the whole process from creating a new application from scratch, from nothing, all the way until it goes to production, and all the steps in between. And I'm going to try to do that in less than half an hour. I'm going to use Jenkins X, and my main goal here is to show you how we can do a modern process, how we can accomplish all the goals set in front of us for 2019 without really going into deep details of the technologies I mentioned before. So let's get on with it. First, I'm going to create a project, right? I'm going to create a new application, and I have here my notes. Let me open them. Give me a second. Here it is, here it is, here it is. My notes. Okay, so I hope that you can see my screen. I'm going to create a new project, and I'm going to simulate as if I'm starting a new project right now. I'm going to choose Go as my programming language. It could be something else. It could be Android. It could be Java. It could be, what do you use in Java these days? Spring Boot. It can be everything except COBOL, I think. Right? I'm going to give a name for the project. I'm going to call it JaxGo, and I'm going to run this command in batch mode. And remember, while I was talking those first 10 minutes in the background, I created a cluster with all the tools installed. Everything I need is already running. All I have to do now is to start my new project. So I'm going to execute this command that will create a new project based on Go. Okay, I obviously forgot to remove my previous test, so I'm going to. Okay, let's try again. Here it goes. Hopefully, 1, 2, 3. Okay, so what I got with a single command, it created a directory on my laptop. It converted it into Git. It detected that it is Go simply because of the files that were put in the directory. It pushed it to my GitHub account, and it created a webhook so that Git can notify the cluster that I created earlier whenever there is a change, and it gave me an output of a few handy commands that I can use. So let's take a look. What did I get now with this command? What did I get when I started the project? So first of all, just to prove to you that it's working, I'm going to go to my browser, to my GitHub account, and you can see here is my project. This is the project that was created, and you can see by the time here. Let me make it bigger, just in case you can see that I'm not faking it. It was created less than a minute ago, and I got everything that my project needs. One of those is a source code for my application, which I will be extending, but all the rest of the files are the files required to configure all the tools that you might know, you might not know, you might want to know, but that really doesn't matter. What really matters is that everything required to combine all the different tools into a meaningful pipeline and a software delivery process is already there. So let's say I'm going to go to that directory that was created just for me. I'm going to show you a few files. For example, I need to build Docker images, so a Docker file was created for me. In case of Go, it's very simple. In case of some other languages, it's a bit more complicated. But Docker file is created. I can build my Docker images, so that's awesome. Let's see about Jenkins X YAML. This is a new format to define pipelines, and this one is extremely simple. It says do whatever is defined to be done for all other Go-based projects, right? I could extend this. I could add my own steps here, but I'm just keeping it simple for now. I'm just assuming that I will be doing with this Go application the same steps, the same process that other people developing Go are going to do. Also got the makefile that defines all the targets used to build, test, install, and so on and so forth, everything I need to do with my code. And now, again, if this would be a different language, it wouldn't be makefile, it would be mainfile or Gradle or whatever you're using. What else did I get? I got scaffold. Scaffold is the way how, I would say, a standard in a way, how we combine building container images and deploying them in one process. And in this case, for example, if I look at the development profile, you will see that it uses Helm charts. It could be something else, and it builds my images with Docker. It could be kaniko or some other technology. So all I'm supposed to change, if I want to switch to different engine for building container images or different engine for deploying my packages, I just change this YAML file and I'm golden. I also got charts. Charts are how we call Helm packages. I got two of them. One that defines how my production grade application will be deployed. That's what this one, Jegs Go. And one defines previews. Previews are the temporary deployments of our applications initiated by pull requests. I'm going to show them soon as well. I'm going to show the process. So far, I'm showing you only the files. And if I show you one of those ChartMuseum chart directories, you will see that everything we need for Helm charts to define Kubernetes packages is already there. You can go deeper, you can understand all the details about it, but if you just want to deploy to Kubernetes and not worry about it, everything is already waiting for you. And finally, the last thing I'm going to show you is my GitHub account. You will see that it's already, not only that it created the GitHub account, it created the webhook, so that every time anything is pushed to this Git repository, it will notify the cluster and cluster will do something about it. We're going to see what that something is very soon. One more interesting thing I need to show you is if I list all the pods in my cluster, you will see that there are a lot of applications, but none of them is Jenkins. This is ChartMuseum, control, no Jenkins anymore, because Jenkins is being, or something similar to Jenkins is being created whenever we build something, and it is being destroyed whenever we don't need, whenever we finish building. So it's truly serverless. And you can see this through those three pods here. They were created, one for my application, one for the staging environment, actually two for the staging environment, and they're all, none of them is running anymore. So at least from the perspective of the system itself, things are running only when needed. This is becoming truly serverless, right? There is no long running Jenkins anymore. Now, if you're curious to see what happened with the application I created a moment ago, you'll be happy to see that I can show you all the steps that were executed, right? My credentials were retrieved. Cluster already knows my credential automatically. I got the source from Git. Tools were assembled. Application binary was built. Container was built. Container image was built, and so on and so forth. All the steps, all the fully autonomous, fully automated pipeline were executed, and the result of me creating an application is that it was automatically promoted to the staging environment. So my staging environment, every time I push something to the master branch, my staging environment will be updated with this new release. I'm not going to show you logs. They're the same logs as in as if you would see in traditional Jenkins. Instead, I'm going to show you pipelines. And what I want to make sure is that everybody understands is that everything that we could do through UI before is now available as commands. Everything is available through the CLI and much, much more. And here you can see that I have three pipelines, not counting dummy, one for my production environment, one for the staging environment, and one for the application I just created. I can also list the applications in my cluster, and there is only one, Jegs Go, release 001, was deployed to my cluster, and it is already running in my staging environment. Now, speaking about environments, if you're wondering what environments are, I have at the moment 3 environments only in my cluster. I could have more. One is the development environment. That's where builds are happening. That's where I can develop my applications and so on and so forth. Everything development relating is there. Then there is a staging environment, which is set to automatically receive promotions. So every push to the master branch goes to staging, and production environment that is scheduled to receive manual promotions. That's where we are going to promote our application very soon. What else? What else did I get with a single command? All the commands that I'm executing now is just to show you stuff. The only real command that I executed was to create a project. Releases in GitHub. I already have my first release of my application. Those are the release notes. Not much is happening now because I didn't do many commits, but normally this would be a combination of all the commits and references to all your issues. Everything would be assembled. Everything related to a release would be assembled here. You can see it, you can inspect, you can share it with your friends. And finally, before I move on, I'm going to confirm that my application is running in staging environment. And you can see it is. I send a request to my application from the staging environment. Actually, let me make it simpler for you. Jegs get applications. Here are the applications. If I copy this address and I send a request, I get a response. My application is already running in staging environment. And all I did was simply to create a new application, nothing else. Now let's see how would the process, the development process, work in this context. So I'm going to open up some other of my notes. Okay. So now I'm a developer, I'm going to develop. So how am I going to do that? I'm going to go to the repository of the application. I'm going to check out the a new branch. I'm going to create a new branch called PR. That's because we all work with feature branches now. And instead of showing you instead of changing my source code through, in this case, Visual Studio Code, I'm just going to use set to modify, make a simple change to the code, because this is not really coding exercise. I'm going to change HTTP example to HTTP PR, just to show you that just to have a simple change that I can show you the results of that change. So I'm going to change my file. I'm going to simulate that I code, and I'm going to push things to Git. Sorry, that was a commit. I'm going to push it to the branch that I just created. And I'm going to go to my GitHub account. Imagine that we already spent a full day developing a new feature, and my feature is finished. And what should I do next? What do all the developers do next? What did I do wrong here? I made a mistake. Let me see. I'm going to open my GitHub account. Checks go. Okay. I'm going to create a pull request of the changes that I made to this branch. So compare and pull request. I'm going to call it whatever, and I'm going to create a pull request. This is now, I believe that this new feature is ready to go through the process. So pull request, and you will see that cluster went, first of all, GitHub notified my cluster that somebody wants to create a pull request. And that started the process. And among other things, the cluster itself returned back to GitHub and notified GitHub that this is the process that is expected to be followed. And the process in this case is relatively simple. This pull request needs to be assigned to somebody, and then that somebody should review the pull request. And once the pull request is reviewed, it should tell that everything looks good, and it should approve the pull request. This is a fairly standard process. So let's go through it. I'm going to assign it to vFarsic, which is me. And you can see here that through Git chat, right? I'm not clicking any more buttons. I'm just commenting on my pull request. It was assigned to me. Right? Let's make it bigger here. This is me. Okay, so what else? In the meantime, while I was thinking to whom to assign, Jenkins X already came back one more time to GitHub and said that, hey, your pull request is already built and it is already deployed to the temporary preview environment. And this is the name of the environment. And this is where your pull request, you can examine it manually. So let's click this link and see, really, you can see that this is a new message. It was saying, before it was HTTP example, I modified the code to say PR here, and this was already deployed to my cluster. I haven't done anything except push things to Git and create a pull request. Now, what should be next? What should be done next? Let me see my notes. Did I forget something? Okay, so next thing we should do is say, okay, I'm Victor, vFarsic. I reviewed the code, I look at the code, etc., looks good to me, excellent. I tested it manually, I tested it automatically, I did everything I need to do, and I should just approve this pull request. Approve. Command, approve, comment, and that's about it. Now, what I cannot show you here is that actually approve does not work because the rules that I set is that somebody other than the person who created the pull request needs to review. So unless one of you attendees jumps here and approves it for me, I'm going to click a button. You should never click a button yourself, but I'm going to click it just to skip waiting for somebody other than me to approve the pull request. But you need to trust me. If this was anybody but me, and if that anybody had sufficient permissions, /approve would proceed further with the process. I'm going to circumvent that problem by merging the pull request. But this is only because I'm and I'm supposed to be somebody else. Okay, so now, what happens after I merge a pull request? What happens? Let me see. First of all, let's see what is happening in a cluster. You can see that the moment I merge the pull request, yet another build already started running. You can see number 2 of the build for the master branch. And right now the steps are running. It is building, it is testing, it is packaging, and soon it will end up deploying it to the staging environment. Yet another release in the staging environment, because staging environment is configured and this can be changed to receive automatically promotions every time we push something to master. I'm gonna wait for a minute. See, I'm impatient. It takes more than a minute, and that's already annoying. Getting there. Okay, let's move on with the slides while waiting for this. Now, I showed you pull requests, and it will be deployed to staging soon. And the only thing missing for me to do after it's deployed to staging, maybe after deploying to staging, maybe I don't have everything automated. Maybe I will manually do some verifications. And I already showed you how my application, my pull request is exposed in a separate environment. But once it is deployed to staging, it will run another, it already finished running another round of validations, verifications, and all those things. And now it is running in staging. And I can prove to you that by sending a request to the staging. And this time, I'm still getting HTTP example because the process did not finish yet. But soon, very soon, it will be PR instead of example saying here. There you go, right? You saw that a moment ago, I had the old release in staging, and the moments later, I have a new release, and you can see by the different message. Okay, so I did all my process. I did my coding. I did my local testing. I pushed it to the branch. I created a pull request. Somebody else approved that pull request. That initiated another deployment to the preview environment. We validated it manually as well. We approved the pull request. And now the only thing missing for me to do is to promote it to production. Right? Now, what are we going to promote to production? Let's take a look. First of all, what do we have? Which applications do we have in the staging environment? Not much is happening, so I have only one application. Normally, you would have tens or hundreds or thousands. So you see that I have one application called Jags Get Jags Go and release 002. So I'm going to promote that specific release to production. How am I going to do that? I'm going to do that with a simple command. Jags, I want you to promote this application and this specific version to an environment called production, right? Because what I have right now is that staging receives automatically promotions and production is manual, because maybe there is a business decision when to promote to production. It's not a technical decision anymore because everything is fully automated, but we are making business decision. Now our marketing department is ready. We can go to production. I'm going to execute this button. And what this will do is that it will repeat the process. And while this process is running, I need to show you this repository. This is a repository that defines my production. And in this repository, Jenkins X already created a pull request. And now it is processing that pull request. And if I show you the changes, you will see that it changed. Before it was, where is it? before this application was not running in production, and now Jenkins changed the repository that defines my production so that release 02 is deployed. So in other words, Jenkins is not deploying anything directly to the cluster. Instead, it is modifying repositories that define different environments, and those modifications are triggering yet another set of builds which comply to the new desire. And I think it's even easier to show you what's happening if I show you staging environment. Because in staging environment, if I show you pull requests, one is closed, you will see that this one, if I show you the changes, you will see that it changed the release from 02 to from 01 to 02. Okay, brilliant. So my application is now running in production. If I do jx get applications in production, sorry, is it production or prod maybe? Okay, just get applications. Oh, okay. Let me see whether actually the process finished. kubectl dash and get production, the pods. Oh, I made a mistake. It was not deployed to production. Let me see, what did I do wrong? Let me see, what did I do wrong? You know, this is the worst thing when it happens at the very end of the process. You discover that, of the demo, you discover that you did something wrong. Oh, things happen. I made a mistake. I was going too fast because I was trying to be on time, and I failed to deploy the production. And I have not enough time to check why. Probably I made some tiny mistake, but you need to trust me that if I didn't go that fast, my application would be running in production, and then I wouldn't be so embarrassed by what's going on. So a bit of fate that what was supposed to work should work if I didn't make a mistake somewhere along the line. Imagine that production is running just as staging is running, because there I did not make a mistake. Yeah, it is. Okay, so my apologies for the last step that failed. Not enough time to check why. This was my fastest introduction to the whole process using new tools that I could ever make. This is my Twitter account. This is my blog post. Those are the books you should buy immediately. And now we have 10 minutes for questions. And in the meantime, while you're asking questions, I'm going to what did I do wrong at the very end so that it was not deployed to production. So questions, please.
All right, we've had a few that are pretty similar. I'm going to open this up to either one of you to answer. So I'm going to kind of combine this into just one question.
Okay.
So my company has strict, my company has strict security concerns about moving off premises and onto the cloud. How do we fit into this equation?
If you cannot move to the cloud, then create cloud yourself. Set up your Kubernetes cluster, run your VMs using whichever technology you need, use OpenStack or something like that to expose it as a service to your end users, because if you work in infrastructure, then your end users are developers and testers and what's not, right? So create your own cloud. Now, whether you can do it or no, that depends on how far ahead you are with those technologies. But when I say cloud, I don't mean necessarily AWS, Azure, and others. I mean cloud-like features that can be on-prem, can be public, does not really matter. What matters is that you're running it somewhere.
All right.
If you give me more detailed question, I will give you more detailed answer.
All right, so moving on to this next one. I would like to get started with Jenkins X. Are the tools that you're showing, do you feel that they're tools I should get right from the get-go? Or do you think that many of them are things I should wait until I have a use case for?
So all those tools are coming out of the box, right? So at the very beginning, what I did is actually I executed JX create create cluster. I execute this command, which created a cluster. In this case, in Google, but it can be anywhere else. And all the tools already installed. All the other tools that that were not installed, like GitHub and whatnot, were configured, and so on and so forth. So it did all the magic. All you have to do is to execute one of the two commands, either JX create cluster, and that works with, I don't know, like 10 different providers. Now, if your provider, including on-prem, is not listed as one of the options, then alternative is to create your own Kubernetes cluster, which is not hard anymore, and then say JX install. So JX install command will install everything you need, while JX create cluster will create a cluster and install afterwards. So you will get all those tools out of the box. Unless, so you would need to specify if you don't want them, not the other way around.
All right. So the next one I'd like to ask to Marcelo, and everyone please remember you can continue to ask questions. This might end up being the last one. So Marcelo, mentioned at the beginning, you're the Chief Technology Officer of Ticked. Was there a something in particular you encountered? I'm rewording the question a little bit, so excuse me. Is there something in particular you encountered that made you choose Jenkins X over other tools, or did you come in already wanting Jenkins X, and could you please explain why?
Yeah, well, that's a really good question. Every time I end up talking about open source, one of the things that I always tell people to look into is the community, because that's actually going to be kind of like your technical support or your client services, however you want to call it, right? And that's one of the things that Jenkins has. He has, just a tremendous amount of support, great community. So that's the reason why not only I look into Jenkins and decided that, but I do that for every single one of my open source.
All right. That looks like it might be it for today. Marcelo and Victor, thank you for the presentation. Everyone, just as a reminder, there's going to be a very short survey popping up in just a moment. Marcelo and Victor, do either of you have anything you'd like to say before we go?
Jenkins X rocks.
Yes, definitely. Take a look at Jenkins X. Also, as Max mentioned, if you haven't participated or attended any one of our jam sessions, please feel free to go over there. I think we're going to have a lot of these type of talks everywhere, as well as some really nice giveaways and presentation, and also growing the community too.
So one thing that I would, two things I would like to add. First of all, Jenkins is awesome, but you need to forget what you know about Jenkins in order for your brain to accept Jenkins X, because it's a huge shift. It's a huge change. It's not iterative like we had before. This is a complete rewrite. Not the logic is somehow, there are some similarities, but it's a completely new product. So forget about Jenkins before you start learning Jenkins X. And the second thing is, Max already mentioned DevOps World, Jenkins World. Come to Lisbon, come to San Francisco, and find me there.
Yes, Victor and I will definitely both be there. Marcelo, we're hoping to get you there in San Francisco. And just so everyone knows, I did put a link to find registration as well as a 20% off code for DevOps World, Jenkins World in the chat, as well as the link to where you can find your local jam. So I think that about wraps it up for today. We have the survey coming up in just a minute. It's very short. And thanks again to Marcelo and Victor for presenting, and thanks to all of you for watching. All right. Talk to you next time.
Thank you, everybody.
Victor. Yep. Have a good one.
Cheers.
Bye.
Bye-bye.